Knowing the condition of natural resources in national parks is fundamental to the ability of the National Park Service to manage park resources unimpaired for the enjoyment of future generations. The Arctic Network Inventory and Monitoring Program is a major component of the National Park Service's strategy to better understand and manage Arctic parklands using scientific information. As one of 4 networks in Alaska and 32 nationwide, the Arctic Network is responsible for selecting and monitoring key physical, chemical, and biological elements in 5 national parks in northern Alaska. Bering Land Bridge National Preserve and Cape Krusenstern National Monument share similar coastal resources and biogeographic ties to the former land bridge between North America and Asia. To the east are Noatak National Preserve, Kobuk Valley National Park, and Gates of the Arctic National Park and Preserve, which extend across a large expanse of mountainous terrain at the northern edge of treeline. Arctic Network scientists collaborate with park biologists as well as managers and other agencies to implement an integrated long-term monitoring program for 28 vital signs. Just as heartbeat and blood pressure are indicators of human health, vital signs such as water quality or species abundance are key environmental indicators of park health. Many vital signs are expected to show change due to global forces like climate change. Scientists from the Arctic Network provide the technical expertise to monitor these vital signs, such as climate and weather, shallow lakes, permafrost, and Dall's sheep. Climate is considered to be the most important broad-scale factor influencing ecosystems. To monitor short and long-term trends in climate, the Arctic Network is evaluating the installation of climate stations throughout the parks that will record weather conditions such as temperature, wind speed and direction, precipitation, snow depth, relative humidity, and solar radiation. Lakes in the Arctic Network provide important habitat for numerous organisms like zooplankton, macroinvertebrates, fish, and waterfowl. Increasing temperatures in the Arctic have been associated with the disappearance of many shallow, high-latitude lakes. The Arctic Network is monitoring long-term trends in the chemical, physical, and biological characteristics of these shallow lakes. Virtually the entire land area of the Arctic Network is underlain by continuous or discontinuous frozen ground, commonly referred to as permafrost. Climate warming is expected to impact the distribution of permafrost, which in turn is expected to impact regional hydrology, soils, vegetation patterns, and the infrastructure of human settlements. The network is monitoring the spatial extent of permafrost terrain features through aerial photography and remote sensing imagery. The parklands of the Arctic Network harbor a substantial proportion of the world's population of Dall's sheep. Dramatic changes in sheep populations occurred in the late 1980s and early 1990s, concurrent with several years of severe winter weather. Because changes in Dall sheep populations are good indicators of local environmental change, and the species is valued by local residents for subsistence, biologists are assessing and monitoring sheep abundance throughout the network. Crucial to the Arctic Network's inventory and monitoring program's success is the management of long-term data sets. Long-term data collected for these vital signs will extend across the careers of many scientists and numerous changes in technology. Network scientists organize and catalog data, perform data analysis, synthesis, and modeling, and design procedures to manage long-term data sets. Their efforts will improve the lifespan of these data sets and ultimately help future scientists understand the changes witnessed in these parks 50 to 100 years from now.